Afternoon, folks. I just want to take a little bit of time and go over the Postlab questions that I was asking you guys on Tuesday because we didn't really have a chance to do that in class. So I've got two different cups right here. I've got one cup that has 1 mole of water. I have a second cup that has a mole of sugar. So I went in, I got a measuring cup, and I measured out the amounts that we calculated in class. And as you guys can see, these amounts are very different. And it begs the question, why? And I think it's actually a little bit easier in trying to answer these problems if we actually answer them in reverse. If we start with number 2 and then work our way back to number 1. So when we think about a water molecule is not particularly big. It's just H2O, right? 3 atoms in one molecule. When we look at a sugar or a glucose molecule, there's a ton of atoms in that molecule. Check it out. Tons of atoms. 6 carbons, 6 oxygens, 12 hydrogens, tons of bonds. It's a really bulky atom. So just simply by thinking about these two molecules and thinking about the atoms that are in these molecules, we can see that sugar particles are very clearly bigger. How many particles are in a mole? That's right, Avogadro's number, or 6.02 times 10 to the 23rd. So that means we have the exact same number of particles in each of these containers. It's just that sugar molecules are bigger because they have more atoms in them. So how much a mole is depends on the substance that we're measuring. That's one of the reasons why in class I always want you guys to write down the substance as well as the unit, because the substance matters, and especially when we get into chemical equations and balancing reactions. The type of substance matters. Are you working with sugar? Are you working with water? It really depends. Okay. I also just want to take a little bit of an opportunity to just get in a little bit of practice with you guys in terms of working through some mole problems. So let's take a look at a couple of practice problems real quick. First practice problem is just asking us to find the number of particles in 1 mole of baking soda. Go ahead and solve number 1. How many particles are in 1 mole of baking soda? All right, let's see if you're right. It's not really too terribly challenging, this one, honestly. All we have to do is we've got to take the number that we know, 1 mole of NaHCO3, that's the chemical formula for baking soda, NaH, there we go, CO3. And we've just got to multiply it by Avogadro's number. So we know there are 6.02 times 10 to the 23rd particles, which I'm just going to abbreviate as P to save some space and time. There we go, NaHCO3. And we know that this number is equal to 1 mole of NaHCO3. And even though the numbers are very different, because the units are also different, the amounts are exactly the same. It's kind of like saying there are 12 inches in 1 foot, right? 12 inches is the same length as 1 foot. And so I can multiply my original number by these two because it's basically just 1 over 1. All we're doing is changing the units. When I do this, my moles of NaHCO3 cancel out, and I'm left with my answer, Avogadro's number, 6.02 times 10 to the 23rd particles of baking soda. Awesome. That is a P. There we go. Of baking soda. Bam. Okay. Let's go ahead and take a look at number 2. So number 2 is asking us to find the molar mass of baking soda. What very useful tool can we use to find the molar mass of baking soda? That is correct. It is our handy dandy periodic table of elements. Using my periodic table of elements, I can go ahead and see that we've got a hydrogen molecule with a mass of 1.01, a sodium molecule with a mass of 22.99, sodium, hydrogen, we've got a carbon atom with a mass of 12.01, and we've got 3 oxygen atoms with a mass of 16. So we can go ahead and add those numbers up. It's always important to show our work, so go ahead, show your work, and see if you can determine the molar mass of baking soda. And we'll see if you're right. Good luck. All right, time to see if you're right. So sodium, we've got 1 atom of sodium, we've got 1 atom of hydrogen, and we've got 1 atom of carbon, and we've got 3 atoms of oxygen. There we go. Cool. So what I can do is I can multiply these 3 numbers by their molar masses. Sodium has a molar mass of 22.99. Hydrogen has a molar mass of 1.01. Carbon has a molar mass of 12.01. Oxygen has a molar mass of 16. And the units for all of these are just grams per mole. There. Okay. So when I add all of those numbers up together, I should end up getting the actual molar mass of baking soda. So 22.99 plus 1.01 plus 16 times 3 plus 12.01 is 84.01 grams per mole. Nice. Did you remember your units? Good. We always need to have our units. We don't really necessarily need a type of substance in this problem. We're only talking about baking soda, but it's not necessarily a bad idea to not have that substance in there as well. But there we go. Cool. Okay. Last problem is number 3. How many grams are in 1 mole of baking soda? So what tool are we going to use to solve this problem? Good. We're actually going to use the molar mass that we just calculated. So we know we've got 1 mole of baking soda. 1 mole of NaHCO3. Okay. And what we're going to do is we are going to use our molar mass to convert it into grams. So our molar mass is 84.01 grams of NaHCO3. There we go. Per 1 mole of NaHCO3. Why did I put my moles of NaHCO3 on the bottom? Good, because I needed my moles of NaHCO3 to cancel out so that I would be left with units of grams of baking soda. Okay. And that's just 1 times 84.01, or 84.01 grams of NaHCO3. Cool. All right. I'll catch you guys in the next video. Have a good one, folks. Bye-bye now.